This is going to be primarily on Chapter 2, and it'll be considered Part A because it is review. We'll do a separate section to do the other parts, and I may run into a Part C. So we'd like to display our distributions. We talked about it a little bit in a previous lecture. We have variables, and we have distributions of them, and we have various methods of displaying them. Bar charts and pie charts for categorical variables, histogram stem plots, and time plots, and actually dot plots for quantitative variables. So we look at each variable and then we compare the minimum, the maximum, frequency of distribution, etc. within that, and we look at relationships between various variables. So the graph or graphs helps us, and we have some numerical summaries, and we'll see as we get to that what we're talking about. So we look at a particular individual, and it can be described by some characteristics. Some of the characteristics, categorical, may place into one or several groups. For instance, if you're looking at a person, you may say married, you may say male, female, you may say divorced. Quantitative, you might talk about the height, the weight, all sorts of things. And we look at a particular categorical variable, such as ice cream. Pie chart will show you, perhaps the percentage of people who like vanilla compared to chocolate or strawberry. Bar graph could show the same thing. Quantitative variable, histogram, you might look at the ages in the classroom, split it up into frequency intervals. Might do the same thing with the stem plot. The distribution of categorical is shown here in terms of marital status. Same thing is shown here on a bar chart. As soon as you see either one of these, it's categorical. Pie charts and bar graphs are going to show only that. Now, if you look down here, all right, I was trying to get the mouse to show and click, there it is. Even though these bars are close together, this is not a histogram, it's a bar chart. It can be shown instead of going up and down, which I guess you could call vertical, left to right, which would be horizontal. Histograms will never be shown horizontally. You typically will be given these types of numbers. This part here you would be expected to find in order to find the percent of totals for each one, and so that you can make this. Now, your vertical axis here could represent a couple different things. Here it represents the weight, so you're going strictly from here. If you made this 100%, then each one of these would represent something like 20%, 40%, 60%, 80%, and so on. So the histograms are going to show you the distribution of the quantitative variable by using bars, and the bars will typically touch each other, but not all of them necessarily. Stem plots are going to separate each observation to what's called a stem and a leaf, and then plot it to display the distribution. But it'll keep the original values. Time plots we haven't gotten into yet, so I'll wait a bit on that. The dot plots are going to be similar to histograms, except you have a dot above each one. And they're actually similar to stem plots too, because you'll have the original value still in there. So to make a stem plot, you're going to separate the observation to a stem, the first part of the number, meaning the first part is the leftmost, and a leaf, the part that's left. So you put the stems in a vertical column, and to the right of that, you'll draw a vertical line, and then you'll put the stems. I'll show you what we mean here. So here's the vertical line. To the left is where you're going to have your stem. To the right is where you're going to have your leaves. Now this indicates if you're doing this in pounds, this is 100 pounds, there are no examples, so it's left blank. 110, there are no examples, so it's left blank, and so on. There is an example for 135, so the 5 is put in. If there were 2 examples, there would be a second 5, typically separated by a comma or a space. I'm not sure what they mean by the S down here. quite frankly, but I'll try to find out for you. Now, sometimes there's not very many stems. For instance, if this data only covered 10 through 19, that's a very small range. So instead of putting, they've got this as 150. So if this data only covered, say, 100 to 199 pounds or whatever it was, that's a short range, small. So instead of putting 1,5 in a number and then another number if we had a second one, they split the stem into two pieces. The first part right here would cover 150 up through 154. The second part, the other 15, would cover 155 through 159. And they split the other stems as well. That shows in the book, and I'll see if I can get an example posted up there for you if you haven't seen it yet, but you should be able to read your chapter there and find it quite easily. Histograms, you have to make your own individual intervals, and they're all the same size. And typically, if you have an interval such as 0 to 10, the 0 is on the left of the bar, the 10 is on the right of the bar. And if you have a value that's a 10, it does not go into that interval. The 10 on the right is not included. The next interval would be 10 to 20, and your 10 would go into that interval instead. So you're going to count these and see how many you have. Now, if you have something like 50, and you have 25 count, you may change this into a percentage on the vertical axis. 100% in that case, you'd go up to 50%. Anyways, we do examples, you'll see more clearly what it is. So here we see is the number of students. It's pretty clear that from 100, and what's this, 120, 120, 140, 140, 160, and so on. Now over here this means 100 included, up to, but not including 120, there are 7. Now if you total the number of the count here, you change each one to percent. You could put something like 100% here and mark these as 20, 40, 60, 80, things like that, and you'd have these as percentages instead. Either way is fine. So we'd like to look at some pattern. Let me go back here for a second. You see how this is kind of centered roughly around 160? You have an outlier over here at 260. This is an instance where we have actually a space between a couple of the bars, but all the others touch. As soon as you see these bars touching, you know you have a histogram. The spread is how wide it is. Our spread here goes from 100 to 280 roughly. And we have that outlier on the right hand side. So is it symmetric, left skewed or right skewed? The red hill thing that looks like a hill on the bottom is symmetric. It's the same on the left as on the right from the center. Left skewed means it kind of tails off. It keeps extending that way, and it can tail off quite a distance to the right or left. Then you have right skewed. This is actually typical of populations. You don't see these bars anymore. So the bars we're talking about a sample. This is typically talking about a distribution for a population. So in this one you see we have a couple of outliers, one for Alaska, one for Florida. Now we're going to have a formal definition for an outlier later, and it's actually just a made up number saying if it's this far away, it's an outlier, so we're going to consider it. It's a pretty reasonable thing to do, and you'll see that a little bit later as well. So time plot shows behavior over time. So getting to the time plots a little more here. And time's always on the horizontal axis. So we might be looking at something like the temperature every day at noon. So the vertical axis would show the temperature in Fahrenheit or Celsius. And along the horizontal axis we'd show the days, maybe January 1 through December 31st for a year. And we look at a pattern. And you know there's going to be some patterns here. In wintertime it's going to be colder than in summer typically. Here's a few examples of what that might look like. You can pause this and look at it in more detail if you'd need to. And we're going to stop this one for now. This is our review.